In concept generation, you happen for concept generation, then we have to evaluate of the concept generation. It's correct, good, bad, everything. And you have to put it all of the risk management or reliability. You have to put it. It's not correct once you design a new concept and you say it is good, it is completely good. No, you have to put it based on that. Any failure modes you have to put there, and also analysis of that. Analysis of if the failure is affect what happened. This is based on your job. So I call it the risk management number 2, and the risk management number 2 today, and this is the last or subject, is about the failure mode and effects analysis, FMEA. Most of the industry, they use it FMEA or FTA, but most of them they use it FMEA because it's more reliable and more detailed. As I said, all of the industry, all of the project, all of the design, and every company, they have to use it for their design. So in the risk management number 1, we talk about the reliability and safety, but now, as I said, we have to talk about the failure modes and effects analysis, and then fault tree analysis. So we talk about the why we need a reliability and safety, and then based on the reliability and safety, we discuss about the reliability. You have to calculate how much is that. We have a talk. I talk with you. Some of the system is serial. Some of them is parallel. Some of them is combination. Most of the design these days is combination, or you can say hybrid of them. So now we have to talk about and you understand how you can calculate of the failure of that. How can reliability of it. Definitely one of the questions, as I said, I will ask you first based on the reliability. What is the failure? We have to, for the failure, we have to understand about minimize probability of failure. Failure, it happens after a while. After, depends on the time, maybe year, maybe second, maybe month. We have to find it of the failure. Maybe we have, it happened, and then try to minimize of that. Definitely, it's not possible. You say we don't have any failure. The failure is 0. So we have to say about the minimize of that. In risk management, actually, our job is about the identify about the what is the failure is we have, which one. It's not possible after it happens you say this is the failure. Nobody cares. During your process of the designing, you are using the before the production, you have to say and identify all the causes actually of the failure and failure relationship. And our job is improve the design and executing product and the system. It means reduce of the probability of failure. It means reduce of that. Definitely we have a failure, but our job is reduce of the failure. This picture actually, it shows up about the during the time failure rate is changed. As you can see earlier, failure is increased earlier and then becomes late. Some of the rate of failure increase after a while. Some of them is constant failure. Some of them it observed failure rate, and then it changed during the time. So our job is about the understanding about this. It says about the some of the failure we have to identify in the first step, and then we have to clarify of that. So one of the method is FMEA, failure modes and effects analysis. The aim of that is to manage design related to the failure based of the identify the failure modes, assessment of the risk magnitude, and judgment of the acceptability of the risk magnitude. So, in generally, this is, I like everybody understand the whole of this flow chart. It is about the whole of the concept of the failure modes and also effect analysis. Identify possible failure modes. It is your job to find it, failure modes we have. In final exam, I show you the picture, and the picture comes from the device, hardware. For example, engine, okay? And I divided to the different parts, and I ask you choose some of the parts and then identify each of them parts, not all of the engine. In the engine, we have many parts. Identify possible failure modes we have, or we call it fault 3. Then the next step is calculate risk due to the failure, FMEA, and after that ask a question. The question is, are any risk too high? If yes, you have to propose the new concept generation, reduce risk and repeat process if it is very high. If very low, then continue monitor for new failure modes. Okay? So, what I am saying is about we have, for example, an engine. In engine, we have a different parts. You take one part of them, and one part of them you try to find it, identify the possible failure, calculate of the risk, and you see this is the calculation is high risk. If yes, we have to propose the new concept for reduce of the risk and repeat process. If not, we go to find the new failure modes, okay, for that. Look at this is very good example for the FMEA. As you can see, this is the, what is this?
Windmill. Windmill.
Tell me.
Windmill.
Okay. As you can see, this is the this is the turbine for renewable energy, and then it works based off the wind, and the wind direction comes to this actually about the blades, and once the blade rotated, we have generated the electricity. Yes? How many parts is there? You can see we have a lot of parts. Blades, you can see the gearbox, we have a pitch. Our pitch is the part, rotator, and in the rotator actually we have a generator, controller, we have high speed shaft is there. So many different parts is there. So again, for each part we have to apply of the FMEA. So identify the possible failure modes for each part, for example for gearbox, and then calculate FMEA. If it is the risk is too much, we have to reduce of that, otherwise we go to the monitor for the new failure modes. Identify the possible failure modes in this figure. Which part of them we can consider? We can use this table. And the table is failure mode and effect analysis, FMEA. If you go to any industry or any company related to the design, definitely you can see this table. Three things is important in the table. Please step by step come with me, because this is very, very important subject, as well as I will ask you in the final exam. OSD. OSD, you can see here, OSD is here. What is the RN? It means a multiplication. O multiplied to S multiplied to D, we call it RN. Again, Rn here, it means OSD, multiplication together, we can calculate Rn. What is the O? First, what is O? O is risk of occurrence. How much is that? Okay. You can consider from 1 to 10. Okay. So, severity of the occurrence, it is S, we call it S. And the risk of non-detection, maybe you cannot detect something, what is the risk of that? We call it D. So multiplication of the OSD, we put it O here, S here, and D here, multiplication comes here. If we consider O is 10, Rn is 1000. Is that correct? Okay. Three things is important to fill it this form. In this column, excuse me, three things is important to this column, to this table. What, how, why. What, how, why. Please everybody write it in your paper. It's not there. You put it what, how, why. You have to answer to FMEA what, how, why. What does it mean, what?
What component?
What component? Very good. Thank you very much. What component? Look at this shape, you can see which component or what component is there. You can see yaw motor. You can see about the gearbox. Okay. So what it is the component. How many depends on the figure I give you. Maybe 10, maybe 20. But normally I ask you, I don't know, 3 or 4 of the parts, not too much. So, for each component, how what? How failure mode. You have to say about this failure, how it happens, or we have this failure, how. And the cause, it means why. Why it happens. So please everybody understand what, how, why, and then fill it this form. Okay? Then, how comes to this table? How, you can see here, how failure. What it comes from how many parts we have. Choose one part, 2, 3, 4. how you can choose one of the failure example here. Is it finished this failure? No. I just bring it for you, some of them. In the final exam, I give you this how modes. You can go to the appendix and you see how modes we have. But if you ask Hamid, it is all of the failure? No. Most of the failure, it happens from here. For example, elastic deformation, thermal shock, okay? Fracture, something. So, based of the component, based of the part you choose, you have to choose the mode failure, okay? Electrical, you choose one electrical, the failure you have to find it how. Not electrical, you choose not correct mode. So the failure, as you can see how, we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and consider 10 here, 20, 21. Yes? 21 how we have, but if you go to the industry, how means many, many failure we have. But I bring most of the failure. But depends on the failure part, you choose failure mode. It means choose how. Not one of them doesn't have failure and put it there. Okay, this is how. How we can put it here. So based on this table, we can fill it this table. And for y, as I said, y is cause. It comes to this table, cause. How many? I put it maybe 6. We have maybe more. More failure y is happening. The failure mode how and why is different. Why it happened, how it failure we have. Okay? Again, you can access to the why and you see maybe in the failure you put it in overload. Overload, you put it, for example, the turbine, wind turbine, it overload is there, is broken. Is that correct? So this is, we call it why, overload. Or poor maintenance. For example, every 6 months you have to maintenance, poor maintenance or repair, some of them, you put it there. It means why. Environmental factor, condition and something like that. Or any material, specifically poor material, if you choose, you have to put there. And poor design also is one of them. For example, it has a lot of stress. Okay? So, which part of them do you like to choose? Back to the shape, which part of them we can choose? Shaft, yeah? And then we can put it shaft here. Shaft failure. For the shaft failure, identify the actually failure modes is shaft, and then we have to answer what shaft failure, how, and why. Okay? For shaft, how, you have to put it the mode, and why it means a cause. Okay? Is that correct? Step by step I am going through, and then you understand. Maybe how, actually, how means type or mode. It means fracture or play in assembly. we have a how. Please write it in your paper. Shaft failure. One of them is plate assembly and fracture. So based of the how, why caused? It means what? Why it caused? You see, a slacking of the knot during the impulse loading or load not identified correctly, it means happened. You put it in the why. Okay. So far, any question? So, we write it what, how, and why, yes? Anything else we have to put it in the table? Is about OSD, is that correct? Okay. Write it here, failure mode and effect analysis design. As you can see here, the name of the department, anything you like to write it. Write it shaft, and the shaft fracture, for example, and failure caused is the complete breakdown, and what and why type of the loading not identified correctly. How much is the O occurrence? 3. Who give us 3? You, as an engineer. How about the S, severity? You, as an engineer, not as a worker. And D, it means non-detection, it means 10. 3 multiplied to 10 multiplied to 10, it means 300. Another part is bearing. It is what? How? Play in bearing assembly. And why? Slacking of shaft not during operation. Okay? It is why. And the O is 3, S is 8, and D is 10. 3 multiplied to 8, 24, multiplied to 10, 240. Is that correct? So maybe ask me, Hamid, how can I understand OSD is that? How much is that? O occurrence, I give you this table. This table is said a likelihood. Likelihood means probability. Likelihood of occurrence extremely very high is 10. Very extremely unlikely, it means 1. Can we put it 0? No. Between 1 to 10. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very extreme high it happens occurrence, and very low is this. Between these, as you can see, number 4, number 3, number 2. And what is this? You see, extremely high, 1 or more in every 2. It happens. High, 1 in every 5. 5, for example, 5 years. 5 in 5 months, for example, every five. In every 20 years, 25 years, 100 years, I don't know, every 100 months, okay? If you see 1 or 2, it happens very quickly, we call it number 10. It's, you see, its chance for occurrence is very low, you can use it number 1, okay? Who use it number 1, 2, 3, 4, 5? You. From O. And then we put it here 3. What does it mean 3? It means very small chance. Okay? Very small chance it happens for the shaft fracture in occurrence. And then S. S is severity. Is 10. 10, how much is that? What's the 10?
Catastrophe.
Is 10, 5, 2. What's the maximum? Is 10. And 10 comes to this severity. And as I said, 10 is serious and 1 is affected, not noticeable. Very low, very high. So, between 10 and 1, you choose numbers for severity. Who choose that? You, as a mechanical engineer. So maybe you ask me, Hamid, can I choose 10 only me? No. Most of the industry, all the mechanical engineers, they sit together and they have to write it down, and such as the reports, and say, okay, we consider the severity is 10, and maybe he doesn't accept, we have to convince him it is 10. Maybe he'll convince us. It's not possible just you say about the 10 and everybody accepts. So you have to fund it based of the information and background and choose one. This is for S. How about D? Non-detection. Yeah? Non-detection for this case is 10. It means we cannot detect. So it comes from here. You see? None is 10. Chance of the detection none is very bad. You cannot detect. Almost certain, it means 1. So between 1 to 10. So back to the O, 10. Back to the S, 1 to 10. D, 1 to 10. And based of that, you choose one of them and then put it in there. So as you can see, accuracy is 3, 10, 10. It is S and D is maximum. But O is roughly good. So we have to find it Rn. Rn is the risk number. Rn means O multiplied to S multiplied to D, and then 3 multiplied to 10 multiplied to 10, it means 300. Any questions so far? Risk number, it tells us about what is the magnitude of the risk, and the risk is 300. This number can be varied between 1 or 1000, because it's 10, 10, 10, it is 1000. And if 1, 1, 1, it means 1. We don't have 0. Can we put it 0? Why? Because definitely we have for each of the component we have a failure, and we have to detect of that. If you say one of them O, S, D is 0, completely wrong. One of the question is how many parts component we saw in the picture? How many? How many?
Many.
Any. maybe 20. Huh? Maybe some of the device is 10,000. I heard it Boeing airplane has 6 million parts. All of them, they have to put it failure. All of them. Okay? Huge. Yeah. So therefore, you have to identify each of them, multiply together. So this is very high, 300 or N. 300 risk number is too high. What should we do? As I said, this is very high. We have to go back to the try to reduce of that. Is that correct? So how can I reduce? Tell me.
Propose solutions.
We found it about the work for the accuracy, severity, or detection, and then you try to reduce of that. In this case, 10 is too much, or O was 3. So therefore, we cannot change the 10 and 10, S and D. Maybe we can change it the accuracy, and then 3 change it to 1, and then you can see it means improvement, or improvement is 1, 10, and becomes 100. Can you put it in your paper? It is the last part. The last part is improve situation, apply the steps, and you found it cannot change the 10S, 10 from the D, only we can change it the O. This is one part. Another part, as you can see, we can write it bearing 3, 8, 10 becomes 240 because it's multiplication of that. We try to reduce of the failure, but by using the reduce of accuracy, and then becomes 3, becomes 1. As you can see, it was 240, huge. We change it to the 8. Maybe you say, Hamid, as an engineer, you can put it 1, 1, 1. It's easy. No, it's not correct. So during the failure and analysis of that, all of them, it has a standard, and you have to use it always. Behind of this number 3, 10, 10, as I said, we have a standard. A standard tell us about the material, it tell us about why, how, something like that, and then we try to reduce and replace with the material. This is definitely, if I put it the material metal here instead of this, it cannot broke it. But if the plastic broke it, so therefore we have a table, and we can use it for the OSD, and we can use it this. But in the class, in the final exam, I'm asking you to put it the many failure component, and each of the components write it about how and why, and then show the calculation. Once the calculation finish about the current situation, you say, Hamid, this is the current situation we have, but I said 300 is too much, 240 is too much. We try to reduce of that. How can I do it? We can call it improve situation, and then 300 becomes 100, 240 becomes 80. Okay? So I show you the picture about the occurrence. It happens, severity is that, and detection is something like that. So this is very important about check it and then say about the risk now. Fault tree analysis. Do you understand this one? Any question? Do you have any question?
So for the exam, we don't need to provide the proposed scenario, is it? We just put the rating, is it?
Yes, you write in this, but use it the correct of the component. Based of the component, try to find it the
Consequence.
or how, and based of the how, actually find it why.
But the proposed scenario, we
The
don't.
purpose scenario, it should be this one is higher than B's, and then you try to use it.
But we don't need.
Reduce.
But we don't need to provide the.
No, you don't need it to explain to me. If you fill it this form, I expect that you understand very well.
Okay.
Because the table explain very well. It says you try to reduce of the O or S or D, and then it is you understand how you can use it the failure mode. As I said, if you remember 2 nights ago I told you, and I started the class, in the mechanical engineer you cannot see this. In electrical you cannot see. But once you go to the working industry as an engineer, I'm talking not as an engineer or manager, definitely you have to do that. If you don't have it, you have to ask your staff prepare after this failure. Otherwise, after a while, after the year later, 2 years later, you fault something, and they report you over as a manager for that, and this is your responsibility. I'm telling you, some part of them is knowledge, some part of them is about the experience, and I bring for all of them together as a management of mechanical design and research. Another method is fault tree analysis. I like to tell you about this because some of the companies they use it, but most of them they use it FMEA, but FTA also is there. We use it the FTA with the different samples, and the base of the different samples you can see about the event. We use it the box. Basic event, top event, it means a start point in the top. Basic event, it means circle, and we use it the this, or we use it the this sample. And intermediate, it means the between the top and the bottom, we can use it the intermediate event. Undeveloped event, we use the this, and transfer in or out, we can use it the in is this and out is this with these samples. Maybe you say, what does it mean samples? Samples, it communicates with you and another engineer. It doesn't need it to talk a lot or something. Samples tell us about everything from the failure and fault, actually. So we use it the top, we use it this box, or we can use it between the top and the middle. We use it and, it means and, or, you know, between the difference between and or. And also we use it undeveloped event or something. So I give you the example, you understand. So consider, so I read it for you, and then I give you the example. For the FTA, developed a block diagram by using these samples, okay? And then develop the block diagram of the system being analyzed, identify and list of the top level of the fault. It means using this as the top level. Identify events that could cause the identified top level event, then link events using FDA logic symbols. It means you have to show the event, okay? And then event may be this, and this. I give you the example, you understand? Then identify event that could cause each intermediate event. Link events using the standard logic gates. Repeat 3 and 4 until the fall tree complete. Once the complete, it shows the basic. Okay? Complete, it means this or this. It means basic event or undeveloped event. It means finish. I give you the example you understand. Okay?
Is this final exam?
It's not the final exam. No. But it's good to understand because it gives you the more analysis of the fault of the system. So the system is started from here, and the end, maybe the event, maybe this, it means independent event, or undeveloped event, it means finish. So, we repeated the 3 and 4 until we go to the basic or undeveloped this event. Then analysis of the interrelationship include the likelihood, creative action, document, and review. Based on the shape, everybody can write it, but not first. First, you diagram, show the diagram, and you see the diagram, everybody accept. Then, after that, you try to write it and read it. So, consider you have a job review, yeah? And you come late. Wake up and travel to office and arrive for job interview. And then you fail it. You didn't come to the job interview. Yes? You have an interview with me for job, but you didn't come. Yeah? I have to give you your job to her. Okay? No? Why you didn't come? So, I write it for you. Maybe here, late for a job interview, maybe it is or slept too much, or maybe transport failure. Which one? Which one happened for you? You didn't come to the interview. Which one?
Both.
Too much sleep or transport failure? Which one? Sleep too much. Okay, sleep too much. Sleep too much, or maybe lazy, or alarm didn't sound. Because normally staff, they have to alarm the clock. Maybe the clock doesn't work, or maybe you are understand of that, but you are lazy. Sorry, it's not about you. So, just as example. So, another things, this one is finished, lazy. If it is lazy, finish. If alarm did not sound, is or alarm set incorrectly, or alarm failed. Eh? If alarm doesn't work, maybe this or this. Yeah? How about this is the side of the sleep too much? How about this one, transport failure? Transport failure is car failure, it happens, or train, and train does not run on time. And if train does not run on time, maybe a track failure, train failure, it happens, or have some of the works they are working there. So I'm telling you, you didn't come to the interview, we divided the two intermediate of that, and then we can divide the different parts. Based of that, based of these, we can write our report. How can I write it? How can I write? From top to bottom or bottom to top?
Top to bottom.
Huh?
Top to bottom.
Normally bottom to top, we write it for that. And it happens for failure. Okay? Or fault, sorry. So, another fault tree analysis, it is about, as I said, social or something interview. But this one is the electrical. So for the electrical motor, it means fail, cannot work. What happened? Many options. Motor problem, switch doesn't work, battery we don't have it, wire problem. So many of the fail, you have to list it. List is difficult. It's better just show by FTA. And you can see, I put it the failure this. Maybe motor failure, finish. Maybe not current motor. You see, we have a no motor failure, finish. Maybe current doesn't work. So maybe no current current to motor. It means comes from the switch, comes from the wire, fuse, as you can see here, and the power supply failure. It has a different option. And then based of the false fuse, actually false circuit open, we can two option. If the false fail here, it means finish. If it is not false due to the overload, we have to identify about this. As you can see, in the FTA, finish by the circuit, and we call it event. One of them is right here, it means unload, undeveloped. You see, I told you, back to the symbols, as you can see, undeveloped event can show this. But basically, any event we recognize, we use it the circuit. Back to here, you see, undeveloped is here. It means switch left open. And then, similar as you can see, switch is left open, it means undeveloped. Any question? Is that clear? Another fault tree analysis, it is your exercise. And then you can see about the exercise, and then this is activity if you like. Any question? No? Very quick is not it is not, I don't ask in the final exam, but I like just to understand about the assembly also is very important. Manufacturing and assembly is very important because this is related to the mechanical engineer. I don't ask you any question for this, but it's general information for you is important. Design for manufacturing, you can back to the here and then you see about the how we can do the failure mode and FTA. Once you do that, we try to design manufacturing assembly. We have to try to use it the DFMA. It means design for manufacturing assembly. I just try to major subject is estimate of the cost, reduce of the cost, reduce of the cost of the assembly and component, reduce of the cost of the support production, consider impact of the DFM. It means design manufacturing, manufacturing design for manufacturing and decision and factor. So all of them, I put it in the one flow chart, and based on that, you try to do it. So I give you the example from the manufacturing. As you can see, we can have a minimized overall component because this is one part of the manufacturing design. So you can see about we have a different component. Then, as I said, minimize overall of that. Which one is good to less component? And then we go to the design with the base component for one thing of the component. You can see which one we choose for the design. Also make the of the chamfers and leads and complaints of the fatigues, and then based on the fatigues we can find it which one is the less of the issue for that. So I'm telling you, if we have a morphological analysis for the assembly and manufacturing, and then you put it the different list and graph, and you found it okay. For the analysis, we have to follow the different of the function and the component, and which one is the best for using. Also, we have a lot of examples and a lot of things. As I said, the goal of the design is reduce of the number of the parts, develop a modular design, use a standard components, design parts to be multifunctional, design part for multi-use, design for ease of the fabrication, avoid spread fast shares. So what does it mean this? It means this is the sum of the constraint and border for you. Once you try to design, we have to consider DFM-A and then follow all these 7 steps and then try to design correctly. I don't have anything to tell you in the class. I'm here. If you have any question, ask me. How's the course? Good? I think you are happy with course, but definitely in future you are happy more. If you have any question, if you have any problem in future related to your job, because you get 2-3 years as an engineer and 1 year, 2 years in Australia. After 2 years, 1 year, you can get a manager, and the salary and the wage is high. Normally, engineers is $100,000 per year. Manager is 200.
Cool.
Yeah. So after 2 years, this subject will help you, really, because you have to know about how you can manage with the